Basic statistics, measures of center. In statistics, we often use the word average to represent a measure of center. However, there are many types of measures of center. Three of the most common types are the mean, median, and the mode. Let's begin with the mode. The mode of a data set is the number of categories that occur most often in a data set. A data set that has two modes is said to be bimodal. If a data set is fairly uniform shaped and there is no one category that stands out, then we say that the data set has no mode. One important aspect about the mode is that this is the measure of center that can be used for qualitative or non-numeric data. Some examples of finding the mode. Suppose we have a survey where 35 students have brown eyes, 21 have blue eyes, 10 have hazel eyes, and 8 has green eyes. The mode for the eye color for this class is brown because that is a category that has the most responses. As another example, suppose we're given a number set, 1.5, 1.5, 4, 6.5, 8, 8, 10.5, and 12 cc's. In this data set, it looks like there are two modes, 1.5 and 8. So we say that this data set is bimodal and it has two modes, 1.5 and 8. The next measure of average is the median. The median of the data set is the middle of the list, the exact middle of the list. But they first need to be put in some meaningful order. So the steps for finding the median is to first sort the data in some meaningful order. After this, you find the middle of that data set. Now you have two possibilities. If you have an odd number of data in your data set, then the median is the middle of that. If you have an even number of data in your data set, then the median is the average or the mean of the two middle values. Let's take a look at an example for finding the median. Let's say we have a set. This is already in order, 1.5, 4, 6.5, 8, 10.5, and 12 cc's. First note that this is already in order. Next we count 7 items on the list, so we have an odd number. So the very middle of that data set is the fourth spot, which is 8 cc's. So that this is your median. Let's take a look at another data set. We have 81 pounds, 101, 102, 92, 140, and 125 pounds. As you can see, this data set is not in order. The first thing to do is to put it in order. Next, we notice that we have 6 values. So this is an even number of data points. We find the two middle values, then find the mean or the average of those two values. We get this by simply adding the values and dividing the sum by 2. So the median in this case is 101.5. Some comments about the median and what this number is good for. The median can also be used in categorical data as long as you can order that data in some meaningful way. For example, if you have letter grades, you can order it in some meaningful way so you can collect and find the median. The eye color data is an example where you cannot order the data in a meaningful way, in which case the mode is the only option for a measure of center. Another important property for the median is that it's not affected by extremely low or extremely high values. A simple example is that if a company had 3 employees with weekly salaries of $300, $400, and $500, clearly the median is $400. If the $500 person gets a raise to $1,000, the median will not change. This is good for finding the center of data sets that are skewed. For instance, when there are reports of the average home prices here in the San Francisco Bay Area, they report the median. Now let's take a look at the mean. The most common reported average is the mean, or arithmetic mean. The mean takes into account all the values of the data set. The formula for the mean uses a notation that explains the process for computing it. The Greek capital letter sigma comes from the letter S in sum. Sigma x says that we have to add up all the data points. N is the number of data points in your set. So after adding up all the points, you divide by the number n. For samples, we usually represent the mean by x bar. Sometimes we want to represent the whole population, and we use the Greek letter mu, m for mean. To do an example, we have to make sure that our data is qualitative. Note that you cannot add or divide non-numeric data. Let's say we have a set of numbers, 1.5, 4, 6.5, 8, 8, 10.5, and 12 cc's. Add up all the numbers, and we get 50.5. Then we divide by 7, the number of numbers that we added. Our mean for the data set then is 7.21 cc's. Some comments about the mean. The mean can be used only on quantitative data. Also, since the mean uses all the values in its calculations, the values are in the extreme high or low ends will affect the mean. For example, let's take a look at that 3-person company again. The mean of 300, 400, and 500 is $400. However, if the $500 person gets a raise up to $1,000, the mean will change from $400 to about $567. Quite a big difference from the median.